Hello everyone, are you able to hear me? Great, great. Extremely sorry because my laptop got rebooted and I think I need to do something about it. Alright, so before we start, do you have any questions for me? Alright, alright. Let me create notes for today, 25 October, 7 a.m. Alright, so there's a question from Shashi, and the question is, do you recommend any reference book? I would suggest definitive guide. All right. So yeah, there's a question from Srini. Yeah, question from Srini is that all the data is stored in HDFS. So what kind of data is stored in HBase? So it is, if you have to think about it, you should think about it like this. At the end of day, database also stores its data in the file system, right? So HBase also stores its data in HDFS. At the end of the day, everybody stores its data in HDFS. So when you want to upload files, you want to uh, upload your the files which don't have any structure per se, you upload them into HDFS. Okay, you want to insert records. When you want to insert records, update records, and so when you want to deal with data in the form of records, then you go with HBase. Okay, so files go in HDFS and records go in HBase. Okay, so if if your data is continuously appended to a file, and that's the only need you have, then you go to HDFS. In case you go back and forth, update the record, delete the record, so you all do, so you do all that kind of work where you are editing record, then you go with HBase. In HDFS, if you try to delete a line in a file, it is equivalent to adding a fresh new file. Okay. Therefore, you need to understand that HDFS is for files, that to adding and deleting files, not updating files, just like your normal file system. Makes sense now, Sydney? All right, good, good. So, any other question before we start our discussion today? All right. No questions? Okay. Okay, Shashi's question is regarding JVM. I have sent you an email with a link. If that works, otherwise we'll see something else. Right? So today we are going to discuss HDFS, Hadoop Distributed File System. Okay. So as we have told you in the last discussion that HDFS is probably the uh, most important component of Hadoop ecosystem. We would like to uh, go in details. All right. So instead of go in a linear fashion where I tell you what is HDFS, we will try to do a little bit of exercise, okay, and try to understand why did we need such kind of thing in first place. All right. Now here's a question for you. Let's say you need to store 100 terabyte of data. How would you store it? How would you build such storage which can have 100 terabyte of capacity and still it has a backup and data doesn't get lost? Okay, so the question to all of you is, let's say you decided to store all the movies and everything, and you want to build such kind of storage. Okay, so what will you do? All right, Muruke says that divide the data in multiple pieces when we store. Okay, and Harita says distribute it into multiple computers. Brilliant, brilliant. Keep going, keep going. So let's say you are living in a society or you are living in a hostel, and all of you said that okay, you have got lots of movies and it might lead to 100 terabyte. Now you want to store it at a common place so that all of you can watch it at a later point of time, and you want to build this kind of storage, and all of you should be able to add to it. Anand says use multiple computers connected in a network to distribute data across. Brilliant. Keep going. Keep going. All right. All right. So this is what you have been suggesting. So you bought 100 hard disks or maybe 100 computers with 1 terabyte each, and then connected them in the network. And after you have connected them in the network, you shared the hard disk of each of these computers in the network such that these hard disks are available to each other, and then you went to a couple of machines and mounted the hard drive in one in each folder. Okay, so that there is some top level folder called main folder, and under that there are each folder, drive 1, drive 2, drive 3 is mapped to the actual hard disk in, available in the network, and you do this on couple of computers. Okay, so this is the way we generally built network attached storage or storage area network. All right. So does anybody have a suggestion for? Like, what kind of problems does this architecture have? Anyone? What kind of problem will it suffer from? Have we started the recording? Yeah, we have started the recording. Rohit says it's not reliable. Mukesh says that data, reading that data, since we are storing in multiple computers. Okay, so reading that data will be difficult. That's what he's saying. Srini is saying that it will increase the network traffic. Okay. Kamal is also suggesting that network slow speed. Okay. Haita suggests the latency while reading the data. Okay. Anand says if one node is down, need to plan for a backup. That is correct. All right. Good. Good. Now let's say for backup, what we do is along with one hard disk, we put another hard disk and build something called RAID 1. RAID 1 means having one level of backup. Okay. So along with one hard disk, we put one more hard disk for the same data. And so that means we'll buy 200 hard disks and place that data here. So every time we write in the drive 1, we also write in the backup of drive 1. And that way we can build a backup system. Do you think that's a good enough? Correct, correct. Thank you, Steve, and thank you, Dilsad. No, that will not be a sufficient backup because computer itself can go down. Thank you, Dilsad. Yes, and Anand says that backup should also be on a different location. Disaster recovery strategy. Okay. Now Mukesh says that we need to have some logic to assemble this data. Yes. So as per Mukesh, he was suggesting that split the data across the network and put it somewhere. Good, good. You're going just little step ahead, and good. And we Dilsa suggests that we need to have failover support. Brilliant. Now, what other problems do you see? Let's understand what other problems are there. One is that the network can go, drive can fail. Okay, even if there is a backup which we planned just now, the computer on which both the hard disks are there, that computer might go down. Okay, the network cable could get disconnected or whatever. So the whole data lying in one particular hard disk will no longer be accessible. All right. Now, question is, what are the other problems do you foresee? Yes, that's correct, Steve. What if both hard drives go down? Yes, that's correct. What if you have a natural disaster? That is correct, that is accepted. That is one of the problems. So, one is that your whole computer might go down. Second is that the network accessibility problems would be there. All right, all right. Murkesh suggests that what if computer that have the main folder that goes down. Okay, good, good. For that, what we can do is um, we can suggest all the people to have multiple computers on which this mapping is available. Okay, but again, in case one computer goes down, anyway, the data is lost. Yes, Anand suggests that network traffic may be more at a particular node if more people are accessing the same node. Alright, so what we have done is we have created this kind of a structure in which there are these drives and sort of backup we have planned, but not good enough. So when we are storing data, we will store we will index the data in some way, saying some data goes in drive 1, some data goes in drive 2, some data goes in drive 3. Do you think that will be a problem? Okay, carry on. Yeah, yeah. Not same data in this drive because we are building a 1 terabyte of storage and there are 100 folders. Now, where should we keep which file? Okay, how should we? Let's say one way could be that we 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 designate each hard drive for each of the file name. All the file names starting with A will go in drive number 1. All the file names that starting with B will go in drive number 2, and so on. I mean, do you remember having multiple hard disks in your PC, and you always have to plan which stuff goes in which hard disk? Yes, divide and distribute the data. That is, yes. All right. So, so in a sense, these are the main challenges which we will face this with this kind of storage. What about failures and backup? So there's a difference between failover and backup. Okay, who can help me with in defining the difference between failover and backup? All right. Harita suggests that there is a need to be equally distributed, but the data need to be equally distributed, and also we still one copy, so chance of data loss brilliant, brilliant. That's what we are saying here. Good. Steve suggests that we need to replicate the data across multiple drives, across multiple locations. Brilliant. And Anand suggests that failover is business continuity and backup is restore data in case of data loss. Great. All right. I'll take what Anand has written, and this is well written. All right. So, so backup is you took the backup in case your machine goes down, you can manually take it out and restore it from the backup. Failover is that if machine goes down, immediately the control goes to another machine and we start serving the alternative copy of our data. That is failover. There is another system who has an alternative copy to give out. Alright. So the challenge is how would you distribute the data uniformly? okay, that we have already discussed. Is this the best value for money? We bought one TV hard drives. If we had bought smaller hard drives, we would end up with many more hard drives, and we may not be able to manage. Okay. And also, if there is a smaller hard drive, and then we are trying to upload a bigger file in it, then that will be we will not be able to fit the bigger file in it. Or imagine this: we designated a folder for a drive, and a folder is smaller. Sorry, the drive is smaller, and there is only 1 gigabyte storage remaining on a disk, and we are trying to put 1.1 gigabyte movie. Now we won't be able to fit that movie in the remaining amount space, and that remaining space will remain forever, right? So those kind of problems will arise. So we are not buying a smaller disk, or maybe we have smaller disks lying around in a network from the past, but we are not using them. So is this the best value for money? Is this the best use of resources? Now, there is one more important aspect. Somebody has actually pointed out, one of you have already pointed out, that what about availability? Imagine this. You built this network for movie sharing, and suddenly it's the Independence Day, and everybody wants to watch the uh, movie for about Independence Day, or it's some celebrity's birthday, and everybody wants to watch a particular movie of that celebrity. Now, now all of the people would be trying to watch the same movie from the same disc, and the disc, and everybody will try to read the data from the same disk. Effectively, what would happen is that disk will get that the disk will get hammered badly and will crash. Okay, because a hard drive is bounded by physical boundations, and therefore it cannot cater to many users parallelly, because it has to rotate, and there's a header that moves from one place to another. Therefore therefore the system is not fairly accessible. If multiple people want to watch the same movie, they cannot watch the same movie at the same time. Scaling out, this is something very important. Today we have a need of 100 terabyte. Tomorrow we might need 200 terabyte. And in that circumstances, again we have to juggle with all of this. So we added more computers, we will start moving some data from existing computers, and then we realize that okay, our whole scheme is gone. Okay. And other than that, locating data in this structure is difficult, right? We'll always have to build kind of an index saying this kind of file go in this particular machine, this kind of file go in this particular drive, and so on. We basically have to build sort of a index. Make sense to you? So that's where the HDFS comes into play. So you will be surprised that this is how we built the file systems in early 2000s. Okay, this is how we actually built the file system in early 2000s. Okay, by combining a lot of hard disks, and by telling people that this is where you have to store your data. All the data related to this goes in that drive, and all the data related to this goes in this drive, and so on. So we basically tell all the people that this is how you need to organize the data. Okay. So I so very well remember using such kind of systems and building such kind of systems. And Interestingly, I was talking to a client who basically stores really huge data, and they still have exactly this kind of infrastructure, and their problems were exactly what we have talked about. All right. Now, to solve these kind of problems, we have something called HDFS. All right. Let's jump in. Now, I think everybody is ready to listen to that, we need a file system, because prima facie, if we if I propose to you that we need a file system, you will say that what's the point? Okay. Good. All right. Let's have a look at it. What exactly is HDFS? Okay, a little bit about history. HDFS is Hadoop Distributed File System. It was designed based by people of Hadoop. That was the first component that was designed. Those people who are trying to build the Nut search engine, and they built it based on a paper from Google called Google File System. The Google File System was meant for storing the globe size data, as in the data from the whole world wide web. Okay, that's the reason why they built HDFS. They faced the problem in building the nut search engine, and they needed something to store data at. Because hard drives is cheap, computers are cheap, they're not too costly. So even if you want to build your own cluster, it's not that big a deal in today's time. Now, the HDFS cluster, so the basic component or the basic things that we need to first understand is an HDFS cluster is made up of two kinds of nodes. There is only singular node called name node, and there are many nodes called data nodes. And at the end of the day, all of these are basically services. The way your machine is running in background, some services. Similarly, admin node is also a service and data node is also a service. Okay, we'll go keep on going more and more into details of these things. Now, as we were just telling that if we have to spread data in the network, we will require some sort of an index telling what is where, and that's what the admin node is. Admin node keeps the information that this file is located on this disk, this file is located on that disk. So if we ask what all files are there, we can just ask the name node at any point of time, and name node will give you the list of all the files, the name of all the files. Okay, the actual content, the actual data is stored in data node. Okay, actual data is stored in the data node, while the listing or the information about each file, the permission, the timestamp, the created date, and and all of the basic information around the file is stored in admin node. This information is called metadata because it's a data on data. Okay, so data on data is called metadata. And also, since lots of people will be asking about the files very often, and there is a single admin node, they will therefore, to make the whole process faster, name node keeps the whole metadata in the memory. Okay, you can think of metadata as the directory structure, big directory structure, and and the actual blob, actual content is in the data node. Blob is big large object, big large binary large object. I forgot what we call it, but blob means big large object which doesn't have metadata information. Okay, so this is HDFS. Okay. So regarding the failover and the redundancy of name node, we will talk uh, furthermore. Okay, Steve, and we will talk in more details. All right. So that's probably the most common question which comes to our mind, and that's a very valid question. That what if name node goes down? We'll talk about it again. All right. Now, now there is one more thing which we all will be, astonished with. The files are not stored as is. The files are broken into the blocks of 128 MB. Earlier it was the default value was 64 MB, but we will stick to 128 MB. So by default, when you store a file, the files are broken into 128 MB sizes. This helps fitting very big file into small disks or small remaining spaces. Now you can see in the diagram on the left, imagine had these instead of these balls, imagine big square blocks. Okay, big big cuboids or big cubes. Okay, there'll be a lot of space that would be left in the jar. So the only way to fit lot of data into something is by making them small pieces. Okay, so and that is why the files are broken into small blocks and kept on the data nodes. Now this basically leaves less unused space on the disk. So, two details. One, we maintain an index of all the data in a separate machine, and that machine is called name node. Okay. Second information is we break down when while storing the data, we break down the file into 128 MB and store those blocks. Okay. So please note that when we are breaking the file into blocks, when we are breaking the files into blocks, the last one is generally smaller block than 128 MB. Okay, so if we have say 200, let's say 300 MB. Okay, what will be the block sizes? And this block size is configurable. That's correct, Dilsad. For a file of size this, what will be the blocks? Yes, 128 MB, and first block will be 128 MB, second will be 128 MB. Okay, so 128 MB into 2 and 300. So last one will be 44. Perfect, perfect. All right. So the way data node will be storing this data will be in the local file system, because data node at the end of day is basically a data node is essentially a normal computer having the local file system. It may be running on Windows or running on I mean running on the it may be running on Windows or running on the Linux or running on Mac. So it will be having the local file system, like C colon or D colon you have in the files in your machine. So data node will be storing this block as a file in your file system. And the last block will not take 128 MB. Instead, it will take lesser amount of space. If it's not like in our case, last block will only have a file of 44 size. So basically, this data node is storing data as a file in the local file system, and it doesn't leave any kind of a uh, extra storage. Okay, so the first data node will have 128 MB, second data node will have 128 MB, while third data node will have a file of 44 MB size. Okay, so all I'm trying to say is the data node stores the data in the local file system. Okay, and that's how the whole system works. It's a high HDFS is a high level file system which utilize the low level file systems to actually store the data. Okay, so now this dividing the file into blocks has multiple benefits. It optimizes the data transfer. Tomorrow, when you are adding one more computer, it's very easy to just move some of the blocks to the new machine, as well as it is very easy to distribute the load at any point of time. We added a file and we realized that one of the machine is having bigger, more blocks. We'll just remove some of the blocks to another machine. So it's very easy to basically load balance. Yeah. So earlier, now Dilsad's question is 128 MB block size recommended? Yes, kind of. If you try to, if you're expecting bigger files in your file system, you generally go for a bigger block size. But as a thumb rule, we do not interfere with the 128 MB block size. Okay, let it be, because it is done based on certain heuristics. Imagine this. So if there are bigger block size, okay, if there are bigger block size, then we will have less of mobility, and the benefits of having smaller blocks are obvious. But we do not have very small blocks. We don't have blocks of, say, 1 KB size. Okay, if blocks were of 1 KB size, what would happen is the name node will have lot of information, because name node has to keep track of all of this. Name node has to keep track of that. Okay, I have got one file, I have got 3 blocks. This block is stored on this data node, this block is stored on that data node, and so on. So if we had very small block size, what would happen is what would happen is the name node's metadata would be humongous, would be very humongous, and assembling a file will take more time, will may not take more time, yeah, but the metadata will be too huge, and looking for metadata will take more time. That's the reason there is a there is neither we choose a block size too high, nor we choose block size too low, too small. All right. So Dilsar, does that answer your question? All right. Here is an interesting question from Anand. So in this example, we be able to see 3 physical files of size 128 MB, 128 MB, and 44 MB. Yes, I will show you. I mean, and make sure that you remind me, and I will show you that there are these files. Okay. All right. So you can see, you will be able to see that there are these files. All right. Now, Pankaj's question is, could you explain how splitting files into smaller blocks help leaving less unused space? Now, imagine this. Now, you see there is only small space available. Now, if you try to store a big ball, you can't fit it in. But if you cut it into small blocks, then you will be able to fit some part of it. Yeah. Otherwise, okay. All right. How should I explain this? Um. Okay. I would like to explain it. Let's say we have three big boxes. This is one box. This is another box. Okay. And this is another box. Okay. Now we have these big ball, and or maybe we have another these round objects. Okay. Now we want to fit these into these jars. These are the containers. Okay. Now, now, if you do not break this, you won't be able to fit it in. Let's say we put it here, and then we try to put it here, and then we try to put it here. Now we are not able to fit these things into these jars. But if we break it down into small portions, if we cut it into small pieces, then we will be able to store these objects into these jars. Okay. So basically, that is how. So if you are able to break them into small pieces, you will be able to fit them in and have less unused space. Okay. Yeah. So you can basically put lot of stuff if you have. All right. Does that make sense to you now, Pankaj? All right. So this is how, if you break down things into small chunks, you will be able to store lot of small pieces. Okay. Now Murkesh's question is, what is the minimum size of data node hard disk? So you cannot have data node hard disk less than 128 MB. You can have data node hard disk bigger than 128 MB. Okay. But generally, you generally go for the money for. So you look at the market, and in the current market, you generally take a look at uh, hard disk divided by the space divided by money and buy it. But I will explain to you further that while buying hard disk, it makes sense to buy more hard disk than buying bigger hard disk. Okay, so if 4 terabyte is the one which is more value for money, I generally go for 1 TB each. Reason being, while buying a hard disk, it's not only the storage which I get, it's also the reading speed which I'll get, and therefore buying multiple hard disks of a little smaller size will make more sense to me. Okay. Now there are a few more questions, really interesting questions. So if there is a cluster of 4 nodes, then max file size that can be saved on the data will be. No. Okay, it's not compulsion that one machine will only have one block. Okay, it is no compulsion that one machine will have only one block. One machine can have multiple of your blocks, so one node could have all these three blocks as well. All right, your theory was valid only if it was forced that one machine could have only one block of a file. All right. There is another question from Murukesh. So we can use HDFS only if file size is 128 MB minimum. Not really. If no, there is no such compulsion. Okay. Even if imagine now let me go back to this question again. So what if we have 3 MB file? Okay, 3 MB file, and our block size is 128 MB. Okay, so what will be the blocks? Anyone? For a file of 3 MB, what will be the blocks? Correct. It will be one block of 3 MB. Thank you, Anand. Thank you, Haritha. Thank you, Dirpu. Thank you, Pankaj. All right. Good. So does that answer your question? Now here is an interesting question. So in the example above, 128 MB, 128 MB, 4 MB blocks will be in the same node? No, not necessary. Name node will take a decision and will try to keep it in different machine. All right. All right. So I think there. All right. There is two more interesting questions. Let me answer those, and then we will move on. These are very important to answer now because they will you will miss these questions later. How big does RAM need to be for name node? Generally, if you are setting up a cluster, you generally go for around 8 GB RAM. I mean, that's not required. I have run a cluster with 2 GB RAM also. Okay, so but it's generally comfortable for name node to be with 8 GB RAM. Although you can definitely run the whole system with 1 gigabyte RAM as well. If you can run a virtual machine, Java virtual machine in certain memory, then you can run your name node. Yes, good point. Good point. I was coming to that. Yes, it is the duty of name node to figure out which block will go in which data node. Okay. All right. Good. This is an interesting question. Who can answer this? Let me see who can answer this. I pinpointed a problem earlier. Okay. So let me see who can answer this. Question is it not advantageous to have all the blocks of a file on the same node? Can anybody give the reasoning? So here's the question, this one. Is it not advantageous if you have all of the blocks? This is the question, Steve. All right, let's try for a one more minute. I hope that the audio is back and okay. All right. So yes. So Dilsad says that it's better to have blocks on separate nodes, and yes, yes. Here is a good answer from Dilsad. Thank you. Answer is to avoid it becoming the bottleneck when client tries to access the data. Now, if the blocks are on different machines, the client can download the data parallelly from all the machines at a very faster rate. So if you have 4 nodes or you have say 20 nodes, it can download the 20 different blocks from to 20 different nodes, and therefore the overall download speed will be far better. Okay. Along with that, if let's say me and you want to watch the same movie, and we basically are lagging by 10 minutes. Okay, so which means that by the time you finish reading the first block, I will start reading the first block, and therefore we will never hit the same data node at the same time. Therefore therefore having blocks in different machines saves our hard disk to from getting overloaded. All right. How much RAM size is required for each node? The data node do not require much of the memory. Instead, the name node requires more memory. Okay. But generally, having a 4 GB RAM on data node is good. But our cluster is having 8 GB RAM on each node. Yes. Another point from Srini, if the node fails, there is a problem of recovering data. Yes. Shashi also suggests that we want to distribute the data to different machine. Okay. Now, brilliant. Wow, the audio is not clear, doesn't seem to be clear. All right, let me just try to reconnect and hoping that everything will be okay. Is my voice clear now? I'm trying to disconnect and reconnect. No? All right. All right. So now we have great questions. Now moving on. Now there is one bit of information which is also very important. Now we talked about breaking the blocks. We talked about distributing data, fitting bigger files into smaller files using the blocks. Now each block in data node has multiple copies. Okay? This is called replication factor. And by default, the replication factor is 3, which means that every block has got 3 copies. Every block has got 3 copies. Ouch. My voice problem is again back. Just give me a second. Let me try to fix it. So, is it any now? All right. All right. All right. Okay. Is my voice better now? Doesn't look like. Ouch. All right. Let me try a few more things. Hi, uh, is it any better now? No? All right, all right. Is anyone able to hear me now? Hello? Hello? Hi, uh, is it any better? I'm not sure. This seems to be okay here. All right, just give me a second, okay? All right. Are you able to hear me now? Okay, let's try on this connectivity for some time and see if it goes better. Okay, otherwise I'll try my third connection. All right. Okay, so we were discussing couple of things. Actually, all of the questions have gone up. If you have I mean, if you have your questions, could you paste it again? Hello. All right, here's a question from Murugesh. Suppose we have a name node, one name node called name node 1, and three data nodes with this three data node 1, 2, and 3, and we have a file 1, and okay, a.txt, b.txt, c.txt, and data node 2 is having c.txt, b.txt, a.txt. Okay, if data node 1 goes down, so all three blocks will get corrupted. Okay, all right. So here's an interesting question. Here is a really good, interesting question. So again, let me recap a bit. Let me recap a bit. So every block is copied, and with by default there is a replication factor of 3. In case in case one of the data node goes down, the replication factor will reduce by 1, and name node will try its best to bring the replication factor again to 3 by creating one more copy of the blocks which have been just lost. Okay, so name node will try to figure out which are the blocks that are lost and immediately start replication of those blocks by using the remaining copies of the blocks, and that actual copying of the data is done by data nodes themselves. Okay, so in this case particularly in this case there is a problem because no two copies of the blocks can be on the same node. So, so, so we cannot have replication factor of 3 on two data nodes. Okay, so basically nothing will happen in this case because we will be left with two data nodes, and therefore it is not possible to have multiple copies. Make sense to you, Murukesh? Yeah. Now, moving ahead, what is the relation of HDFS and Oracle RAC? Uh, honestly, I don't know. Honestly, I don't know about Oracle RAC much. I've not used Oracle RAC yet. Okay. Srini's question is that if an organization plans to build 1 terabyte distributed file system, is it required to build 3 TB cluster? Yes. Okay. So if you are very confident about the hard disk, about the network, you can decrease the replication factor by 1, and you can set the default replication factor as 2. Okay. So let's imagine that you are trying to use solid state hard drive. Now, solid state hard drives are far more faster and more reliable than normal hard disks. And also, in case of solid state hard drives, the amount of data, the amount of storage is generally less. Therefore, you can reduce the replication factor by 1, in case of solid state hard drive, but I would not recommend that. All right. Okay, so here is a slight confusion. So name node is alias. I mean, admin node is alias of name node. Okay, we call admin node and name node as the same thing. We use the word alternatively. Yes, name node will not copy the data at all. Yeah, because here a.txt after first data node is lost, c.txt has got copy on second one, b.txt has got copy on the second one, a.txt has got copy on the second one. Therefore, it will not do anything at all. All right, good, good. I hope I have not missed anybody's question. All right, moving ahead. So now there is a common question which goes on. There is a question from Rohit. While reading data from data node, does it read from all the three nodes? Yes. Basically, it would read the data blocks from the nodes which are free. Okay. It will find out it will find out from name node that where all the data blocks are there, and the one which are most free, it will read from there. Murkesh's question is, do we have any relationship between the replication factor and node, as in what node we are talking about, Murkesh? Data node or name node? Data node. Yeah. So the only relationship between the name data node and replication factor is, if your replication factor is 3, you cannot have less than 3 data nodes. Okay? If your replication factor is 10, meaning one block copied to 10 machines, that means you have to have minimum number of 10 data nodes. That is why while setting up an HDFS, it makes sense only if you have multiple data nodes. It makes sense only if you have 3 data nodes, if you have replication factor of 3. Now, a common question is, why replication factor 3? Okay, so generally, generally we have in normal life replication factor of 3, 2. Whenever we are taking data backup, we take 2 copies of it. But don't you think when we are slicing data into into blocks, don't you think it's more riskier? Now, if you take the case of this one, if you take the case of this particular situation, if you have 3 node and your blocks are spread across the network, now any of the block is lost, your data is lost. Therefore, you have to be more cautious, because the loss of one data node is not only the loss of the data which was on this data node, but of all those blocks which of all those files whose block is on this particular data node. So because of slicing a file into small blocks, if any of the block is gone, the whole file is useless. Therefore, the risk is greater in the HDFS. Therefore, you should have more backup, and that is the reason a replication factor of 3 is kept instead of replication factor of 2. Make sense to you? All right. Generally, how many data node do you recommend for replication factor of 3? Minimum 3 data nodes. Okay? Minimum 3 data nodes. All right? The good part is you can start with 3, and as and when your data is growing big, you can keep on adding more and more data node as and when you want. Okay, that is how it works. All right, now coming to the name node, as we have already talked, as most of you have asked already, that name node is the single soul, as in case something happens to name node, the whole file system will go haywire, right? So let's see what all do we do in order to protect our name node. First is, the name node is, this is not how name node behaves. The way we generally picture in mind is, user comes to name node goes to all the data nodes, assembles the data and gives back to the end user. No. In this case, if you notice, name node will become the bottleneck. If name node starts doing everything, name node's bandwidth is consumed in reading data, and effectively, name node will be busy most of the time. Name node will be the bottleneck. Now, to avoid that, the architecture is a bit different. Okay? Now, the architecture is a bit different. The user is using something called client or a driver, a command. The user is using a command to talk to the name node. And name node will give the name to give the list of files or list of blocks to this driver. It is the duty of this driver to talk to each of the data node and assemble the data and give back to you. It is this command line which does everything for you. This command line talks to the name node and gets the blocks, and then reads those actual blocks from the data node. So the information about blocks is given by name node. So you can see that name node's duty is only to give out metadata, not the actual data. Although name node stays in touch with all the data nodes. Okay, all the data nodes keep informing the name node about their health. All right, let's try to understand what goes on behind the screens. Okay, so a user comes in, goes to the name node, and says that, hey, I want to write a particular file. Now, the name node tells the user back. When I say user, it's the command, it's the client, it's the driver who is continuously having conversation with the name node. So the driver says to the name node that, hey, I want to upload a particular file. Name node says in response that, hey, you need to slice your file, or you need to break this file into a block size of 128 MB, and then you have to store the first block on this data node, second block on that data node, and so on. Now, this client will start storing the information onto those data nodes which are informed to it by name node. Now, as soon as it finishes writing to those data nodes will start internal replication. You can see that client has written this particular block, and this particular block is being replicated amongst data nodes. So data nodes are also fairly busy in doing a lot of backend work. All right. Similarly, in case any of this data node goes down, and name node doesn't receive a heartbeat as in a ping from any of this for some time, it will consider it to be dead, and immediately all the it will figure out which nodes have the lost data and start copying from them. Now, while reading the data from name node, let's say you want to watch a movie, you go to the name node and tell that, hey, I want to watch a movie. I mean, you as in your driver is talking to the name node. So the driver is talking to the name node and asking, asking that can you tell me where are the blocks related to this movie? Name node gives back saying that these are the blocks related to the movie you talked about, and these are the copy of each one. These are the hosts that contain the copy of each of the blocks which we have talked. Now, client will accordingly talk to individual data node and read the blocks, assemble it, and give it to you. Client as in client driver, or you can say connectivity driver, whatever you want to call it. This is the client or the driver who talks to the name node and does all the grunt work for you. So this is called Hadoop, a command line. You use a command line called Hadoop, and then that's how you talk to name node. Okay. So, all right, is this clear? Now there are a few questions. Let me answer this before things become bigger. Or let me just go through once more, and then you will have answer. So this is what is happening. SDFS client is coming and talking to the file system, and so SDFS client is talking to the HDFS file system, and then from here a request goes to the name node. Name node says that here is the list of blocks, and start writing. This HDFS file system will start writing the data, and once it acknowledges that we have received the data, it sends back you the information. And the next step is that you close the file handle, and then while you close the file handle, the information goes to the name node saying, okay, the file has been successfully written, and that's all. All right. Similarly, in case of reads, while HDFS client talks to distributed file system, it first gets the block location from name node, and name node gives you the list of blocks, and this HDFS client will start reading from the data node and then assemble the files. All right. So I hope your question related to these have been answered. Anyway, I'll just if data is in 10 nodes, will it read from 10 nodes at a time because of distributed? Yes, provided you have 10 blocks. Next question from Anand is, once the data node replicates, the information is shared back to the name node about replication? Yes, that's correct, because name node has to be kept aware about whatever is going on. Who does the job of breaking into the blocks while writing and reading? It is the No, name node does not do that. Name node just gives the information that block 1 goes there, block 2 goes there. That's it. It is the client, or you can say driver. Okay? Client slash driver. Client as in the command which we will use to upload the file. It is that command. Like you have JDBC driver. Okay. Now next question is, if data node goes down, then who will copy the block to the other node? So in case data node goes down, they will copy the data amongst themselves. Name node will inform both of them that such copy need to be done. Now where does name node store the metadata? Name node stores the data in two forms. One is snapshots plus transactions. Okay. Snapshots and transactions. Periodically, it snapshots the whole memory into the disk, and whenever there is an action happening, it will write something called transaction logs into the disk. Okay. All right. Who is responsible for replication? So starting with name node initiates the process while data nodes does do the actual work. A question from Steve. Is it possible to have multiple name nodes or replicated name node in case main node goes down? We will talk about it next. Good question. Yes. I think Sumati's question would be, yeah, which data nodes? Yeah, you're right. Which data nodes? Yep. So does name node tell which data node to use to store replicated data? Yes. It just tells that these are the nodes on which to keep the replicated data. All right. Now there are few more nitty-gritties with name node. Let's take a break and then come back, and then we will do more hands-on on HDFS. Okay. Okay, give the example of HDFS client or HDFS. There is a command called /bin/Hadoop. Okay, all right. Now let's take a break of 10 minutes and we'll be back at 8:46 a.m. IST. Hi, I'm back. Should we start now? Hello. All right. Now, a very important topic which probably you all have been asking. Okay. So, there are a few things which we noticed. How did name node avoided itself becoming the bottleneck? First point was that it it did not it did not read things. Instead, it redirected people. Okay, it redirected the driver that do not I cannot read data for you. You go and talk directly to the data node. That is an important aspect. All right. Second is the other ways it avoided being single point of failure is by having, okay, so first it keeps the this is how it maintains the backup. So the whole namespace is periodically snapshotted into the disk, as well as the metadata can also be kept in a network file system. Okay, so that another machine, in case this name node goes down, we can make another machine as name node and bring that to the life. Okay, so one is a snapshot of metadata plus edit log. What does it mean by edit log? Edit log means Edit logs means that periodically it makes the note of that this file was edited, this file was deleted, this file was uh, this file was created. So those are edit logs. Now, using these edit logs and combination of image of the metadata, you can always reproduce the most live metadata. Okay. So the first primary thing which NameNode does is it provides you a way of storing the metadata and its edit logs on two locations. One is in local file system, or you could keep it in another file system in a network file system. That is the first primary thing it does. All right. Second thing it does is second kind of functionality which NameNode provide is called secondary NameNode. Now, as we told you that metadata means namespace is image, as in the current directory structure and current information image plus edit log. This image is created periodically while edit log keep on getting added as and when new action is happening. If you are from database background, you will notice that these are similar to transaction logs. Right? Now, name node keeps on writing the image along with the edit log into the local storage, and in case name node goes down, we keep something called secondary name node. Secondary name node keeps on building itself from the namespace image combined with the edit log. So this secondary name node keep doing it periodically and is available in case name node goes down. But this switching of between name node and secondary name node is manual. Now, this is okay. This is also okay, not so great, because every time name node will go down, in case manual intervention is required, then it's not really a failover. It's more like a backup. Therefore, in Hadoop 2.0, they came up with an idea called high availability name node. Okay, and this is something which works really really well. So what you do is, so there are three things here to note. First, all the data nodes know about name node as well as another node which we call standby node. Standby is actually the standby. It has all the information updated just like name node. So the whole network behaves to standby network, a standby node exactly in the same way they behaved to the name node. Be it the client driver, be it the data nodes, all of these machines, all of these services update name node and also update the standby name node. Okay, so basically every time data node finishes writing the data, data node informs name node that I'm done writing this, as well as data node informs standby that hey, I'm done with this. So anything that happens, anybody who is doing the work is also informing the standby, not only the name node. Even when the name node creates a metadata, creates a new file, or does something, it will inform the standby, and standby will have the most latest snapshot of the metadata. And therefore, so one part is that standby maintains the live data, maintains as close copy as possible to name node. Second is automatic failover. This automatic failover is done using a component called quorum general manager. Okay, when we'll go through our zookeeper, we will study this part. We will study it that how data node quickly convert get the information that hey, now the name node is this machine, not that machine. Okay, so basically that switching between name node and standby is done using quorum general manager, and quorum general manager uses the zookeeper to switch between various services. Okay, so this is probably the most preferred way of running name node. All right, now the fourth step. Okay, second, third, this was actually fourth. First, the fourth step that is taken is making its earlier was secondary name node in Hadoop 1.0, and Hadoop 2.0 standby came into play. Now, the before that, the first in first cut, name node provided the facility to have a backup of the metadata somewhere else. Now, there is one more thing, and because name node is obviously the bottleneck, there is few more things which name node provides you. Today you have few files. Tomorrow, imagine that you have hundreds of billions of files. Now, all right. So today you have few files. Tomorrow your metadata keeps on growing because you are having more and more files in your file system. You have got thousands of data nodes storing hundreds of petabyte of data. Now, because of so many files, your metadata can overflow. Your metadata can overflow, and you cannot have the bigger memory in the name node. Name node might hit its upper memory limit. Okay, you keep on increasing the RAM of name node, but after a certain point you will have to realize that you cannot go beyond a certain size of the RAM. That is when you will face this kind of problem. Okay, so that's when you would require the federation, HDFS federation. What does it mean by federation? Federation means that a file, there are multiple name nodes. Federation means there are multiple name nodes. Although it's the same pool of data nodes, but there are multiple name nodes. One name node designated for one folder, one top level folder, and other name node designated for other other top level folder. Now it will behave as if there are two HDFS in the game. So there are one HDFS this one, other HDFS this one. So it's like having two HDFS parallelly working. But the difference between two HDFS and this one is that here it's the same set of data nodes. This name node is also storing its blocks into the same data node, and this name node is also storing the its data nodes, its blocks into the same set of data nodes. Now, if you see here, we can designate a folder to a name node or multiple folder to a name node. Now, who does this switching? Switching is again done by when client library is having a config file, etc Hadoop, and then under that there is a config file. we can mention in that configuration file we can mention in that configuration file that this folder means this name node, this folder means that name node. And while this cloud library starts, it basically reads this config and then take the decision to talk to which name node. Okay? So this is how the federation works. So we talked about many things as in keeping the backup, keeping the secondary name node, keeping the quorum manager, and keeping the federation. Okay. Again, let me before we jump into hands-on and question answer, let me describe few more things. Again, the metadata in memory means the entire metadata is in. Okay, so yeah, so the entire data is in memory, and this is how the metadata looks like. Metadata is, okay, I have got one file which has got those many parts. Part 0 has got this replica, and it's available on these nodes. Okay, so that is name node. Now name node keeps track of overall directory structure and placement of data block. Alright. Types of metadata, the kind of metadata name node holds, list of files, list of blocks for each file, list of data nodes for each block, as in list of data nodes having copies of each blocks, file attributes like access time, replication factor, file size, and file name. Transaction logs records the file creation, file deletion, etc. Alright, now moving ahead. So this way, the name node metadata is stored like this. The question to all of you is, before I answer your questions, there are three questions I think. Yeah, there is a good question for all of you. If we ask, if we execute ls, ls is equivalent to dir, okay, dir. If we execute these either of these commands on Hadoop, on HDFS, will we be talking to name node, talking to A, name node, B, data node, and C, both, and D, none. Anyone? Co- Correct. It is only name node. Alright? Because we don't need the actual data, so we don't need to go to the data node. We just need the list of file, the name of the files. That's it. Okay? So we'll not go till the data node, Steve, because we don't need it. We don't need the actual data. We just need the list of files. Make sense to you now? All right. Now moving ahead. So essentially, this is how the HDFS works. Now we will do a hands-on kind of exercise. Then we will. Before that, let me go through your question. So Srini, your question is answered, or do you have further doubts? All right. Now Pankaj's question is secondary name node is another computer. Yes, generally a secondary name node is another computer. A question from Murukesh is, what is the my data to etc the folder means? We just created some example here. We just created an example that if a user is coming to create something inside this folder, his request will go to the name node. In case the user is coming to create a folder or file inside these folders, then the request will go to the name node number two. Okay. Now the Rohit, now so okay, this is good. Now Rohit's question is, in STFS federation, does name node as standby name node? Okay, I think you mean heads. Not necessarily, but not needed, but recommended. Okay, so here, if you see, name node 1 is having standby name node 1, name node 2 is having another standby name node 2, and they are talking to the pool of the data node, same data nodes for both the name nodes. All right. Yes, Anand, size of the file will also be in the name node since the ls command shows the size as well. Yes. Murkesh's question is, what exactly is the role of HDFS federation? Okay, whenever our name node gets so overlaid loaded that we cannot help, then we need to break the work of name node to multiple name nodes. In those cases we will use this kind of a mapping. Now question from Sumati is, does name node 1 and 2 communicate with each other? What if name node 1 and name node 2 try to use the same data node to save the data? Good, very good question. No, they don't communicate. They don't communicate to each other. Okay. What if name node 1 and name node 2 try to use the same data node to save the data? Yes, they can. They can. And there is nothing wrong with that. Okay. How do you think? Why do you think it's a problem? Why do you think there is a problem that name node 1 and name node 2 are trying to use the same data node to store the data? What is the basic difference between secondary and standby? Okay, secondary is manual while standby is automatic failover. Sounds good? All right. Now, there's a question from Harita. The question is, but will both name nodes have information of data file in case of federation? But will both name node have information of data file in case of federation? So they will have the information about their own files, only about their own files, meaning files under top level directory. Okay, under top level directory which they are responsible of. Okay, like for example, here our first data node is responsible for this, second data node is responsible for this. All right. All right. Now this is not for failure. I mean, this is not. This is a very good question. What Harita is saying. Her point is that if not, we will still have single point of failure. Yes, that's why this model we are proposing. The way when you have the high availability as well as high failover, you generally go with this kind of a model. Also, this configuration is kept in mount tables. We call them mount tables. They have this information loaded from the config saying this folder is mapped to name node. So anything to do with this folder, you need to go to name node 1, and that folder is if so the my data 2, for anything related to my data 2, all the requests will go to the name node 2. Now this does divide the work between name node 1 and name node 2, but it doesn't lead to the failover. Okay, that's why we have a combination of standby 1, standby 2. You see sb1, sb2, those are standby nodes. Okay, so that's why I have drawn them in the architecture. Are data nodes and name nodes set up in the same geographical location? Not necessarily, but generally you keep them, at least one data node should be, at least some data node should be in the same location. Otherwise, it will be really slow coordination between name node and data nodes. Sumati's question is, if there is only 128 MB available and both are trying to save a block at the same time, will it not be a problem? It will not be a problem. One of them will be able to write the data. Okay. Anand's question is, no chance anytime client library mount tables are overloaded. No, they won't be overloaded because when will they be overloaded? When there are many users. When there are many users, that means there will be many instances of client library, and effectively there'll be more because it's not a service that is running. Client library is not a service. Client library is a command. Every time user comes in, it runs that command. Okay, and it reads the data from the config. The only challenge here is every time you are adding more name nodes, you have to update the mount tables or the client library everywhere. Okay, Kamal's question is how current edit logs will be updated in standby name node. So every name node keeps talking to their standby name node, and that is how all the edit logs are sent to the standby name node. Okay. Question from Srini is, we will control client library mount tables. Yes, you will control. Rohit's question is, in any case, can we have both standby and secondary name node at the same time with the name node? Yes, you can have, but it will be unnecessary. You can have standby and secondary at the same time with the name node, but it will be totally redundant and unnecessary. All right. Any questions at this point? Okay. So we will go on with the hands-on exercises now. All right. Let me have a look at our cluster if it's working. Otherwise, I'll use the older cluster. We have two clusters. One is the latest version, one is a little older version. All right. So let me just open. All right. Where is our, here is the page. And you see, this is our login. This is our login. All right. We have login, copy password, paste password, sign in. All right. So our HDFS is up. Good. This is good. All right. Some of the services are down, but that's okay. One of our person is working on these things. Actually, he's my assistant. And yeah. All right. Let's copy the same login password here also. I'm trying to log in into Hue now because using Hue only, you can interact with file system easily. Okay, so this is your HDFS. See the file browser? This is our HDFS. Although it sounds like there is no files, let's create. These are the other folder structure. Okay. In the data, you see there are some files here. So let's try to see for this particular file, how many blocks are there? Okay. Or should we upload our own file? What do you suggest? Let me just go back to my home folder. So here, to upload the file directly from your desktop, you can click on this and upload. Okay. So let me just upload one of my presentations. I think that'd be okay. It's hardly 700 KB. Generally, you should create your own folder in this. So it has uploaded the file. See that? They uploaded this particular file. Good. And to download, you can download. So this way you can communicate to HDFS from the browser. Now sometimes you might have to use, I'm logging into H3. Oh, H3 is not working. Actually the Valley doesn't work. So we'll have to use SSH for now. If you are on the desktop, on Windows, you can use the putty to connect to the server. Although the browser one, let me see if I can quickly turn on the hue, not hue but Veti, and SSH root. Okay, I'm trying to log in there. Okay, so all right. I'm trying to start a terminal. All right, let me just try to start a terminal. All right, I've started the terminal. Now you can connect to the CloudX Lab from the terminal using this. Why didn't it start? ANSI. ANSI is a way to quickly test if some service is running on a particular port or not. Okay, so where is the, okay, yeah, so we will have to do sudo, and what was that? Sudo node app.js minus p80. Let me check it. So this is the terminal that's working. Let me just start the terminal everywhere. Okay. Okay. Sudo node app.js minus p80. What? not connecting. Never mind, we'll just start it later. Anyway, we can start using h1.cloudxlab. Okay, so one is that here you can see using this is the interface for admin, where you can see the admin interface on 8080 port on H1. For Hue, you have to go to 8080 port, from where you can open the file browser and browse around the HDFS. In case you are trying to log in into console, all these console will work. Right now only H1 is working, but we will fix all the things. Okay, let me first do one thing at a time. Login is this and password is this. Okay, so now we are logged in into our folder. There is nothing right now. We can say Hadoop fs -ls. Hadoop fs command lets us interact with HDFS. Now you can see that there is a file over there. Okay, now if we want to, let's say, edit a file in Unix, we can say nano my file and say something. I'm just writing my name. Alright, and then I'll say Hadoop fs copy from local and my file into some folder there. Okay, now if we refresh here, yes, you can connect to SSH or PuTTY if you have one. That's correct, Harita. Alright, so here is my file. You see, this is the file which I just created and have uploaded there. You can see that. Alright, now if I want to copy something from the HDFS to local file, what will I do? First let me check what are the files available there. Here I am. So I'm saying Hadoop fs. Hadoop fs command gives lot of other sub commands. You can see these are all commands provided by HDFS to you. Okay, starting with append to file, cat, checksum, chgroup, chmod, and chown are for permissioning, and copy from local and copy to local is something very important for you. You can keep on copying the data back and forth using these two commands. If you want to copy some data from HDFS to HDFS, you use -cp. Also, if you want to find out what are the sizes of various folders and files, you can use du. If you want to see the current status of the HDFS, how many files are there, what and how much disk is consumed, you can see -df. Okay, so these are commands very similar to the Unix commands. Okay, so now let's try to use copy to local, and I'll say asterisk spark. Okay, it has copied the file, although it gave some error, but it has successfully copied the file. You see that? We can also use get and put command. That's Harita. Yes, you can also use get and put command. You see, put is there and get is there. Okay, good, good. So if you type Hadoop fs without any other option, it will show you the complete help. Alright, so there are a couple of things here. One is there is a local file system of each machine, and then there is the HDFS folder for each things, and then there is your laptops folder parallelly. So don't get confused. If you want more clarity, you can have a look at installation instructions. Along with that, have a look at the cloud dabs. Okay, Here, Cloud Labs, how is the file system of Cloud Lab looks like. Alright, sounds good to you? Now, moving on. Now, we were talking about something called where. Mhm. Yeah. So to know where exactly Hadoop is keeping files, let's have a look at the configs. So it says that the name nodes directories are these, okay? Name nodes, and the data nodes directories are these. If you go to these data node directories, you will be able to see other things. So you can say, you see that these are this is where your blocks are. This is your block ID. You see the big number? This is every block is given such an ID, and under which you will see you will see all the files. Okay? You will see subdirectory 1, subdirectory 2, block number this. You see that? So many blocks are there. So these are the blocks which are basically the files or sections of a big file. Okay? Yes, Murukesh, using putty is perfectly fine. What is the server name and port you need? Have a look at it here. Okay, have a look at it here. Okay, so you have to put h1.cloudxlab and port is 80. Not port is 80, port is 23, usual one, 22. Alright, is the HDFS clear to all of you? No? No, port 8080 is for our browser, not for port 8080 is for this. Port is 23, 22 is actually, okay? So when you are connecting from SSH, leave it as default port. If you are using SSH command or putty, leave it as default port, which is 22. Console login, use only H1. Use only H1 for now. I'll run it on others also. Okay. Harita is saying that we did not get credentials. You have to log in into my account. Go to this page. You will see the login and the password here. Okay. Login and the password. We don't send the login and the password for the labs in here. Okay. Yes, you can. If you are on Mac, you can either. So there are three things. One is Ambari. Ambari you can access in browser. Hue you can access in browser, and console also you can access in the browser itself. But uh, if you are more comfortable with the SSH command, the usual command, not the browser one, then you can directly log in from here. So let me make the terminal a little bigger. You can simply log in from here as well. You can say SSH, and what was the login? Login is here, SSH this at h1.cloudxlab hadoop.cloudxlab.com. This is saying permission denied for me. We'll have to see that why it is happening that way. All right. So Pankaj's question is, can you show an example of creating a file in data node with its replica? Where is it created? So the all of the work is being done by this simple command, the simple command here. Okay, I'll just log in again. Okay, so when we said Hadoop copy from local, when we said Hadoop fs minus copy from local, it is doing all the things which we have talked earlier. It is creating logs, it is doing everything. Okay, if you want to check what happened, you can you can use this particular command. Okay, you can use this particular command. Okay, it says file not found. Let me correct the file name. Okay, under this folder, what was the file name? This was the file name, right? My file. Let me just show you my file. Okay, it shows you clearly here when you run this command, it shows you that connecting to the name node via this particular IP, okay, FSCK as in file check has started by this particular login. From this place, this particular login has started the file system from this particular IP address for this particular path. Okay, and then it is showing that it is just having one block, that too of 14 bytes. Okay, and it is copied at three location, one here, okay, one here on this IP address, second on this IP address, third on this IP address. Okay, third on this IP address. Correct? And it also says or gives you all the details about blocks and files. Okay, is that good enough, Pankaj? His question is, and its metadata is in name node? Yes. So Murkesh is saying, when I gave the name host name h1.cloudxlab.com, it is giving you host name not found. Strange, strange. Can you just send me the screenshot? All right. Try using Control Shift V to copy paste the password. Control Shift V into the if you open this h1.cloudxlab.com and you want to copy paste the login and copy paste the password, you use Control Shift V here. So you can see the URL here, right, Anand? Yeah, this is the URL you have to use. Now, where is the config file located? Config files are located in CD, etc, and Hadoop folder. Okay, all the configuration is actually stored here. You can see so many configuration files. The console login is a part of which setup, Ambari or Hue or something else. No, this is our this is something else which we have kind of implemented. It's a terminal inside the browser. All right. Sounds good to you? So we were able to upload a file, we were able to download a file to our Linux machine, to our remote machine, and we were also upload a file from our browser from our desktop. Okay. Pankaj's question is, I'm not able to access h1.cloudxlab.com using putty from my lab. Are you providing the login name, correct login name? And are you providing the so make sure that while you are connecting from putty, make sure you provide 22 as the port and the login ID, login name. Okay, only then you'll be able to connect from the putty or SSH. Okay, Kamal, just send me the screenshot. I'll help you out. So, who all is stuck? Just raise your hand. Pankaj and Steve both are stuck. All right. If you're not able to connect through SSH or PuTTY, you can ignore it for now. I will test it first because I mean, let me just understand what's going on. But Steve, but if you're not able to do using VETI, let me know because connecting to VETI should be very straightforward. Go to the browser, type h1.cloudxlab.com, copy paste the login, and then copy paste the password. Okay. Srini's he doesn't have login password for CloudX Lab. Do you have a login password for your LMS? In there, you will see this login password here. Okay. Okay. So Dilsal says that Dilsaz is able to access via VATI on Mac, but not via SSH. Okay. Looks like some problems with SSH. We will check it out. Yeah. Copy to clipboard for password is not copying. Are you sure? It was working for me. Or you can do a show password and then copy. So generally the in VATI control V does not work. So you will have to use control shift V. Okay. So Steve and Dilsad both are able to log in into VATI. Good. Who else? Haritha, are you able to log in using VATI? Okay. So Haritha, what kind of problem are you having with password? Murkesh is saying that he's getting a blank screen using VATI. Which browser are you using, Murkesh? Harita, you can say Control Shift V to paste the password. You can try it. Which link to click for VATI? You just click on the first link here. You see here, do you see my screen? Here, the first link, this one. All right, good, good. So 5, 6 people have already been able to log in the VATI. All right, brilliant. So in case you are getting stuck, just let me know. All right. Okay. So yeah, I'll just clarify things. I think there is a little bit more confusion. So Ambari is part of Hortonworks data platform. Okay. So whatever we have installed is actually the standard way. The way if you join an organization, this is the standard way you will be interacting with Hadoop. Okay. Where and basically that is how the organizations work. They will install the Hadoop in their cluster and you are supposed to access it remotely and get your work done. You will not you will not be using your virtual machine in a real life environment. Okay. And this Ambari is not our product. This is a standard product which comes bundled with Hortonworks. Same is the case with Hue. When you take Cloudera or Hortonworks, they come with Hue. Okay. The VATI is something which we have installed, which people have not installed on their clusters because we realized that people were facing lot of problems using putty and also people were facing a lot of problems with respect to using from SSH. Therefore, we started providing people with the terminal. In an organization, you will be using SSH instead of web terminal. Okay, but both are exactly identical. So, Haritha, uh, if you are typing the password may not be visible to you. Okay, that might give you an impression that you are not able to type. Okay, so looks like Control Shift V doesn't seem to work in IE. I have not tried IE for quite some time. Okay, so Pankaj's question is, we can see our uploaded file with all its replica in Hue file browser. I'm not able to find that. I don't think Hue has that information available. Okay. Instead, use the command which we just run. Use this command which we have just run. Okay. So you can upload the file into Hue from here. You can say upload files and that's it. Okay. So you could go to any of the folder. As you enter, you can click on this file browser on the top right corner and then you can click on upload. Okay, you can see file upload here and then you can select on something like, can you provide list of commands for Veti? Alright, are you able to see, Shashi? It says that the same file already exists, so it cannot upload it. So you'll have to use some other files. Okay, now let's just take this particular file. Now, Srini, the commands that you use in Veti are basically Unix commands. Okay, Unix commands. And if you want me to quickly go through, so ls is list of files, pwd is present working directory, cd for changing directory, and other things which you can do is ls minus help or man ls. It'll give you the manual of ls commands. Okay, try using ls minus la, which will show you the list of files. Okay, and then you have present working directory, change directory, and you can say nano file name for editing a file, and you can use the rest Hadoop command, Hadoop fs command, to upload the file. Sounds good to you? Okay, so for Anand also it has started working. Okay, so who all are struggling yet? Good. So you go through the basic Unix command, that should be good enough. rm is for uh, deleting directory, mkdir is for making directory, and what else? Great, great. So Sumati is able to log in into Ambari, Hue, and Console. Oh, Steve is saying that uh, Hue doesn't work on Safari. This is strange. This is strange because the only reason I got the latest version was that I was told that it works well on Safari. Okay, let me see. h1.cloudxlab.com colon 8888. All right. Let me also try if it is working on Safari. Interesting. It doesn't really work. You're right. So Harita could not get it login and password to work. Is it? For me, I was able to copy paste. Could you use some other browser, please? I don't know. I'm not tested. If you use Firefox or Chrome, it will be good. All right. Anand's question is Hadoop installation will be covered? We are not planning to cover Hadoop installation, but we will give you a quick overview on how to install on cluster. Okay. All right. Dirpu's question is file uploaded to Hue is directly going to HDFS and not local. Yes. Okay. Directly into HDFS. All right. All right. So Anand, we have not yet planned for an administrator course. Okay. But I can give you a quick overview on how to install Ambari. So the trick is very simple. So let's say you have machine 1, machine 2, and machine 3. You plan to install you plan to install Hadoop on these three machines. So what you do is on one of the machines you install Ambari server, okay? While on all the rest of the machines you install Ambari agent. Here, here, and here. All right. So we install Ambari agent everywhere. Once we have installed Ambari agent, and all we need to do is go to open Ambari server, which is this, and go to hosts and log in with the admin. And here you will see add hosts button. Once you click on add host button, it will ask you for all the Ambari agent. So you will write here all the IP addresses of the machines which you want to on which you want to install uh, this Hadoop. And once you specify that machine, it will ask you which service should go to which machine. And that's it. And then it will take around half an hour time to install everything for you. It'll download Hadoop, it will install Hadoop on all the machines. Okay, so yeah. Also, please note that here these machines which we are using are CentOS 7, and all are 8 GB machines. These are all 8 GB machines. Okay, so this is how you will install Hadoop in your in your organization. You basically start with installing Ambari server, then add Ambari agent everywhere, and then you basically ask Ambari server for adding more hosts, and that's it. Okay, so I will share you the link, stepwise link on how to install Ambari or Hortonworks in your cluster. It's not a rocket science, it's very straightforward. All right. Also, you can configure everything from here. You can configure each and everything from here. You can go to config. Just that I have disabled the permission for this particular user right now. Okay. So you cannot administer using this account. All right. That's pretty much for uploading the files and downloading the files. All right. Now, if you want, we can start with our compute engine. All right. Did I miss anybody's question? No. Yeah. Okay. So in Ambari, you can't do much other than seeing the status of various services because you don't have the administrative privileges. This is just to see what is where, what is up, what is down. Okay. All right. Now there is a question from Anand. I would like to answer this question. In real time, take Facebook, all the new data generated will get automatically uploaded into Hadoop cluster by some interface. Yes. We will cover this under Flume. Okay. Most of the data automatically keep flowing into HDFS using Flume or similar agents. Or you might write your own API. Okay. So Harita is telling that by the time she finishes writing the password, it is timing out. Let me have a look at it. Let me have a look at it. We will increase the timeout. Okay. All right. Now there is one more point from. Okay. I log into CloudX Lab. Uh, what commands recommend use to begin? Okay, so any Unix commands you can try, as well as try Hadoop fs commands, and try to use copy from local, copy to local, and all those commands. Okay, Rohit is saying that he was able to copy password Yeah, you were able to copy password. Were you able to paste password into the terminal? All right, good.